Okay, so for today's deep dive, we're tackling something pretty big. One of those fundamental questions in AI, the quest for AGI.
Ah, yes, the big one.
Exactly.
Artificial general intelligence, that white whale.
It really is. In this paper we're looking at today, it's titled, it's a mouthful, A Representationalist, Functionalist, and Naturalistic Conception of Intelligence as a Foundation for AGI.
Quite a title.
Yeah, by Rolf Pfister.
Rolf Pfister, yeah,
And it's not really about, the latest algorithm or some flashy new model. It's kind of taking a step back and saying, okay, what are the core principles we need to think about if we're serious about building AGI?
It's like, laying the philosophical groundwork.
Yeah.
Right? Before you start, building the house.
Exactly.
You got to have the foundation.
The blueprint, so to speak.
Exactly.
So the paper really starts with a very important distinction, and I think this is something that gets lost a lot in the popular discussion about AI.
Okay, I'm curious.
And it's the difference between having a specific skill, like being really good at chess. A program can beat a grandmaster.
Right.
Versus actually having general intelligence, like the kind that we humans, at least we like to think we possess.
That we aspire to, right?
Right, yeah, aspirational intelligence.
That's a good one.
So the authors argue that real intelligence, the kind that's needed for AGI, is about the ability to create new skills on the fly when faced with completely new situations, things you've never seen before.
It's about adaptability, right?
Exactly.
Not just being pre-programmed to do one thing really well.
Yeah, like that chess program. If you suddenly changed the rules of chess, made up a whole new set of rules, it would be completely lost.
Game over, yeah.
Right. But a human, hopefully, with some effort, could figure out those new rules, adapt, and start playing.
That's the hallmark of intelligence, at least as they're framing it here. It's that creative ability to learn, to adapt, to improvise.
And it's interesting how they frame intelligence itself as a sort of meta skill.
Meta skill, I like that.
Yeah, it's the skill of creating other skills.
Right. So it's not just about, being good at playing the piano. It's about being able to learn how to play the piano or any instrument for that matter.
Right. And that ability to learn, that's the core of what they're getting at.
Makes sense.
Now, the paper also has a really interesting take on knowledge. And I think this is important to unpack because it kind of sets the stage for everything else.
Okay. Yeah, let's hear it.
They basically say that knowledge isn't necessarily about possessing some absolute perfect truth about the world, but rather it's about having information that's useful, including those skills we just talked about, so that an agent, whether it's a human or a future AI, can achieve its goals.
So it's more pragmatic.
Yeah, very pragmatic.
It's not about, having the perfect map of reality.
Right.
It's about having a map that works, that gets you where you need to go.
Exactly. And that map can be messy, it can be incomplete, it can even have some errors.
Sure, as long as you don't, drive off a cliff or something.
Right, exactly.
Wow. As long as it's functional?
As long as it's functional, and that's a key word here, viability.
Viability, yeah, we're going to hear that a lot, I bet.
Yeah, I think that's really central to their whole argument.
Okay.
Now, to navigate those tricky, unpredictable situations, where the map might not be perfect,
Right.
the paper really stresses the importance of prediction.
Makes sense. If you can see what's coming, you're in a better position to react, to plan.
Exactly. And for good prediction, you need what they call a world model.
World model, so like an internal representation of how things work.
Yeah, kind of like your own personal simulation of the world.
Okay, got it.
But here's where things get really interesting and maybe a little bit tricky.
All right.
They bring up something called the no free lunch theorems, or NFL theorems.
NFL, like the football?
Not quite, no, though maybe there's a connection somewhere.
Uh-huh.
But essentially these theorems, and they're kind of a big deal in computer science, they basically say that there's no single algorithm that's universally the best at solving all problems.
That sounds a little disheartening if you're hoping for, one AGI algorithm to rule them all.
Right. It kind of throws a wrench in the works, but the paper doesn't stop there. They actually offer a counter-argument.
Okay, I'm all ears.
They say, look, intelligence isn't about solving every possible problem in every possible universe.
Right.
It's about solving the specific problems that arise in worlds with regularities. And our world, luckily, seems to have quite a few of those.
Yeah, like gravity, It's pretty consistent.
Exactly. Or the fact that the sun rises every day.
Most days.
Most days. Yeah, well, unless you're living in certain parts of the world.
Right.
But the point is, these regularities allow certain algorithms to be much, much better than others at solving problems in our specific kind of universe.
So it's like you can tailor your algorithm to exploit the patterns, are out there.
Right, you're playing the odds in a way.
Okay, I'm starting to see where this is going.
But that brings us to another crucial point, assumptions.
Oh, assumptions, those can be dangerous.
They can be. To make our algorithms really effective, we have to build in certain assumptions about how the world works.
Right, you're assuming gravity is going to work the way you expect it to.
Exactly. But the more specific those assumptions are, the better the algorithm might perform, but also the more brittle it becomes.
Brittle.
Yeah, like if you have an AI that's designed to drive a car and it assumes that all roads are perfectly paved.
Ah, I see. Hit a dirt road and suddenly you're in trouble.
Exactly. And that's a real challenge for AGI, finding that balance between making strong assumptions to optimize for performance.
But not making them so strong that the system breaks down when it encounters something truly new.
Yeah, it's a tough nut to crack.
Okay, so we've talked about skills, knowledge, prediction, assumptions. What's next?
Well, let's talk about how an agent actually gets information about the world.
Perception, right?
Exactly. Perception.
The senses.
The senses, but the paper reminds us that our senses, whether we're talking about, a human's eyes or ears or some kind of sensor on a robot,
Right.
they all have limitations.
They do. Yeah. I mean, our eyes can only see a very narrow band of the electromagnetic spectrum.
Exactly. And they can even distort reality in a way.
Distort?
Yeah, like if you think about a flickering light bulb, it might look continuous to us.
Oh, right. Because our eyes can't refresh fast enough.
Exactly. Or the classic example, the sky looks blue.
Right. But it's not actually blue, is it?
Well, not in the sense that the air itself is blue.
It's the way sunlight scatters.
Right. It's how light interacts with the atmosphere.
Fascinating.
So even at that basic level of perception, we're already dealing with interpretations of reality, not some pure, unfiltered input.
Okay, and I guess this is where the idea of representations comes in.
Exactly. The paper really emphasizes that our conscious experience, whether you're a human or, hypothetically, a conscious AI, it's not this direct feed from reality. It's always mediated by these representations.
Representations like internal models, symbols.
Yeah, and they can be surprisingly indirect, like the classic example of the color yellow.
Yellow. What's special about yellow?
Well, we don't actually have specific yellow receptors in our eyes.
We don't.
No. That sensation of yellow is created by our brain combining signals from our red and green receptors.
Oh, wow. So it's like our brain is constructing this experience of yellow from other inputs.
Exactly. And that's happening all the time. Our perception is constantly constructing these representations based on the limited and sometimes distorted data it's getting from our senses.
So perception isn't just a passive process, it's an active construction.
Right. And the paper makes another crucial point. It's not just our senses that provide us with knowledge. It can also come from other sources.
Like what?
Well, think about a database. A computer can access information from a database that wasn't directly perceived by any sensor.
Right, or like the rules of a game. They're not something you perceive directly, but they still shape how you play.
Exactly. So while having good perception is obviously important, it's not the only way an intelligent agent can build up its understanding of the world.
Okay, that makes sense.
Which brings us to this concept of a world model. And the paper defines this as basically everything an agent knows, both its learned skills and just its general knowledge about how the world works.
So it's like the sum total of all your internal representations, all your knowledge, everything you've learned and just know about the world.
Exactly. And they contrast the world model of something really simple, like a water flea.
A water flea, okay.
With the incredibly complex world model that a human has.
Right. I mean, our world models have to deal with time, with abstract concepts, with language.
Yeah, a water flea's world model might just be a few basic rules about light and food.
Swim towards the light, eat the things.
Right. But ours is vastly more complex, multi-layered, nuanced.
Constantly changing. Right.
Constantly changing, yeah. And where does all this knowledge, this world model, come from?
Well, you've got your senses, your experiences, but there's got to be more to it, right?
Right. They break it down into three sources: prior knowledge, perceived knowledge, and derived knowledge.
Prior knowledge, that's like what you're born with, your instincts.
Yeah, or in the case of AI, it might be the initial programming, the starting point.
Okay, perceived knowledge, that's the stuff you get from your senses.
Right.
Direct experience.
Right, and then derived knowledge, this is where things get really interesting. This is the knowledge that you figure out through reasoning.
Ah, so this is where intelligence really shines, right?
Exactly. It's not just about what you see or what you're told. It's about what you can deduce, infer, figure out on your own.
And they talk about different types of reasoning, right?
Yeah, they go through deduction, which is about drawing logically certain conclusions.
If A, then B, that kind of thing.
Right, induction, which is about making generalizations based on patterns you observe.
Like all the swans I've seen are white, so maybe all swans are white.
Right, but then there's abduction, and this is the really powerful one. It's about inferring the most likely explanation for something.
So it's like, I see wet grass, so maybe it rained.
Exactly. It's not certain, but it's a plausible explanation, and it allows us to introduce new concepts, new ideas.
Like Newton and the apple, right?
Exactly. He observed the apple falling, and through abduction, he came up with this idea of gravity.
So abduction is about making those creative leaps, connecting the dots.
Exactly. But the paper also points out that even with abduction, you're still limited by the concepts you already have.
So you can imagine a red circle if you know what red and circle are.
Right.
But coming up with a completely new color, something beyond human experience.
Yeah, that's a whole other level.
Well, that's a tough one.
And they also highlight the importance of abstraction, being able to pick out the important features of something.
Like focusing on the signal, not the noise.
Right, and classification, grouping things together based on their similarities.
Okay, so all these things, these ways of reasoning, they're kind of like the tools in our intelligence toolbox.
Exactly, and how well those tools work, how reliable they are, it depends on how well they match the actual structure of the world.
Which brings us back to those pesky assumptions.
Right, we can't escape them. They're baked into how we think, how we build AI.
So how do we judge if our world model, with all its assumptions and reasoning methods, is actually any good?
Well, the paper says the key metric isn't whether it perfectly mirrors reality, but rather its functional viability.
Viability again, so how well it works in practice.
Exactly. Can you use it to achieve your goals? Can you make accurate predictions? Can you navigate the world successfully?
It's about results, not necessarily perfect truth.
Right, and they argue that this focus on viability has a couple of advantages.
Okay, like what?
Well, for one, it allows for simplification. You don't need to model every single detail of the world to be successful.
Like you said before, you don't need to calculate the trajectory of every air molecule to throw a ball.
Exactly. And it also means that we don't necessarily need to have this, God's eye view of absolute truth.
Right. Our representations can be messy, incomplete, but as long as they work, that's what matters.
Exactly. And they also point out that this view of knowledge as being functionally viable means that it's inherently constructivist.
Constructivist.
Yeah, meaning that our world models are built up from these uncertain conclusions, these interpretations, and there might be multiple valid ways of seeing the world.
So there's not necessarily one right answer.
Right. It's more about what works for you, what helps you achieve your goals.
But doesn't that lead to a kind of relativism? Like anything goes as long as it works.
They do address that. They talk about these things called explanatory virtues, like simplicity, coherence, things that we tend to value in explanations.
Well, we're not just picking explanations randomly. There are certain criteria.
Right, but they also acknowledge that the basis of those virtues and whether they actually lead to better results in the long run is still debated.
So it's still an open question.
It is, and it's a big one. But even with all this uncertainty, the paper argues that the representational nature of intelligence is really what gives it its power.
Because it allows for planning, for imagination, for thinking through different scenarios.
Exactly. We can build these internal models, these representations, and manipulate them in our minds without having to play out every possibility in the real world.
Which is probably a good thing, considering the potential consequences.
Yeah, probably best not to test every hypothesis with a real-world experiment.
Agreed. So what about meaning and understanding? How does the paper approach those concepts?
Well, again, they take a very functional perspective.
Okay, I'm sensing a theme here.
Yeah, they define meaning as a function that we attribute to something in order to achieve a goal.
So the meaning of something is tied to its use, its purpose.
Exactly. And understanding then becomes the ability to use something successfully according to its meaning.
So if I understand what a hammer is for, I can use it to hammer nails.
Right, and they use the example of a green traffic light.
Okay, classic example.
Its meaning, in the context of driving, is you can go. And understanding that meaning means knowing how to react appropriately, taking your foot off the brake, pressing the accelerator.
So meaning and understanding are intertwined.
Yeah, you can't have one without the other. And they argue that we can explain these concepts naturalistically without appealing to, mysterious mental states.
Like consciousness or intentionality.
Right. It's all about how an ager interacts with the world, how it learns to achieve its goals.
So intelligence is about building up these skills, these algorithms that allow you to act effectively based on the information you have.
Exactly. And those skills then get implemented by systems, whether it's the biological machinery of a living organism or the code running on a computer.
And the meaning of something arises from its role in those skills, how it helps you achieve your goals.
Right. Like that green traffic light, its meaning comes from its role in a learned driving algorithm.
And if that algorithm works, if you can successfully navigate traffic lights, then that implies understanding.
Exactly. And information in this framework is simply representations that are used functionally. They have a purpose.
They're not just abstract symbols, they're tied to the real world.
Right. And they address the argument that representations can't be the basis of understanding because they say, look, representations are inherently dependent on what they represent, even if it's an indirect relationship.
Okay, so we've covered a lot of ground here, but how does all of this relate to the big question, AGI?
Well, the paper connects these foundational ideas to the challenges we see in current AI.
Like what?
Well, a lot of AI systems are really good at specific tasks, playing games, recognizing images.
Right, but they struggle with novelty,
Yeah.
with situations outside their training data.
Exactly. And that's because they lack that general intelligence, that ability to create new skills, to adapt, to learn. And they also bring up a really interesting perspective, the phenomenological view.
Phenomenological, that's a big word.
It is, but essentially it means looking at things from the perspective of the subject, the agent that's experiencing the world.
So not just looking at the world objectively, but how it's perceived by the agent within it.
Exactly. And they argue that an agent's perception, its intelligence, is shaped by the world it inhabits, by its own characteristics.
So a human's intelligence is shaped by the fact that we have human bodies, human senses, human experiences.
Right. And a future AGI might have a very different way of perceiving and understanding the world.
Because it might have different senses, different experiences, a different way of processing information.
Exactly. And they suggest that AGI might actually have a more fundamental access to the world in some ways.
More fundamental. How so?
Well, because it wouldn't be as constrained by the pre-existing interpretations that we humans bring to the table.
You mean like our cultural biases, our assumptions?
Yeah. All of that, AGI might be able to see the world in a more raw, less filtered way.
That's a fascinating idea. So it might be able to discover patterns, make connections that we would completely miss.
Exactly. And this leads to a discussion about generative AI, these large language models, the image generators, all that stuff.
Yeah, they're pretty impressive. They can create really amazing things.
They are, but the paper suggests that they're still operating mostly at the level of skill execution. They're really good at specific tasks, but they're not truly intelligent in the way that the paper defines it.
Because they're trained on human data, so they're inheriting our biases, our limitations.
Right, they're learning to mimic us, which is impressive in itself.
But it's not the same as truly understanding the world.
Exactly, and that's the potential advantage of AGI. It could potentially break free from those limitations, see the world in a new light.
And maybe make discoveries that would completely change our understanding of everything.
It's a really exciting prospect, even if it's still a long way off.
Definitely a lot to think about, but I think this paper lays out some really important groundwork for how we approach this challenge.
Absolutely. And on that note, let's move on to our Novel Notions segment, where we can explore some ideas that build on what we've just discussed.
Sounds good. Fire away.
All right, so the paper really emphasizes the importance of abduction, this ability to infer explanations, come up with new ideas.
Right.
So one idea that came to mind is, what if we could build an AGI that not only uses abduction, but actually learns how to do abduction better?
Learns how to learn.
Yeah, it's like meta learning, but for abduction.
So instead of being programmed with specific ways to infer causes, it figures out its own methods.
Exactly. And those methods would be judged by how well they work, how successfully they allow the AGI to understand and navigate the world.
So it's not just learning what the cause is, it's learning how to figure out causes in general.
Exactly. And this ties back to the paper's emphasis on functional viability. If those learned abduction methods lead to good results, that's evidence that they're on the right track.
But there's also a more subtle connection here, right?
Yeah, the paper talks about how AGI might have this more fundamental access to the world.
Right. And if it can learn its own methods of abduction, it might come up with ways of understanding the world that are completely alien to us.
Yeah, like imagine if we could somehow tap into the way a bat sees the world through echolocation.
Or how a bee navigates using polarized light.
Exactly. An AGI with meta-learned abduction might be able to unlock those kinds of alien perspectives.
That's mind-blowing. And what kind of impact could that have?
Well, it could lead to completely new scientific breakthroughs, new technologies, things we can't even imagine right now.
Because it would be looking at the world through a different lens, seeing patterns we've missed.
Exactly. It could revolutionize fields like physics, biology, even our understanding of consciousness.
Okay, that's one pretty wild idea. What's your second novel notion?
Well, building on this idea of functional viability, what if we designed an AGI whose primary motivation was to maximize its own viability in the world?
So it's not driven by some external reward, like winning a game or getting points.
Right. Its goal is simply to exist, to survive, to thrive.
Like a biological organism.
Exactly. And this drive to survive, to interact successfully with its environment, would force it to learn accurate and useful representations of that environment.
Because if its representations are wrong, it might make bad decisions, and that could threaten its viability.
Right, so its actions and their consequences would directly shape its learning process.
It's like learning by doing, but with very high stakes.
Exactly, and this ties back to the paper's discussion of how an agent is embedded in the world. Its learning is shaped by its interactions with that world.
And this could lead to much more robust and adaptable AI systems.
Yeah, because they would be constantly testing their understanding of the world against reality.
And adjusting their representations based on feedback.
Right. It's a very different approach to AI development than what we're doing now.
It's fascinating and potentially a bit scary to think about an AI that's driven by this primal urge to survive.
It is. But it could also be the key to unlocking truly general intelligence, something that can adapt and thrive in any environment.
Okay, so to sum up, we've looked at a paper that argues for a very specific definition of intelligence.
Intelligence as the ability to create new skills, to adapt to novel situations.
And it emphasizes the importance of representations, functional viability, the role of assumptions, the limitations of perception.
It's a lot to take in, but it's all really crucial stuff if we're serious about building AGI.
And it raises a lot of questions like, how might AGI perceive the world differently from us?
What new discoveries could it make? What are the ethical implications?
Big questions, and we're only just starting to grapple with them.
And on that note, I think we'll wrap up this deep dive.
Yeah, a lot to digest here.
Definitely. But for those who want to go deeper, we'll have a link to the paper in the show notes.
Always good to go back to the source.
Absolutely. And as you go about your day, maybe think about this. How much of our current approach to AI is shaped by our own human biases, our own way of seeing the world?
And could a truly alien intelligence, something with a completely different perspective, unlock possibilities we haven't even dreamed of?
It's something to ponder, and who knows, maybe one day we'll have those answers.
I hope so. It's an exciting time to be thinking about these things.
It really is. Thanks for joining us on the deep dive.
Until next time.